All right, I think it's about time. I think we got everybody in that we're going to. So good morning, everybody. My name is Kurt Peterson. Welcome to EAC Presents the Digital Thread, Stitching Together Your Enterprise Data. Let's kind of kick this off by just kind of making sure that we know what we're going to be talking about when we talk about these different terms that we use. If I asked anybody on the call today, what is the digital thread? I think I'd probably get a different answer from everybody. So that's the question I want to start with today is what is the digital thread? And more importantly, why do you need it? Why do we need to use it as modern manufacturing? What good is this digital thread to us? And to put this in context, I kind of wanted to take a step back to how manufacturing has been done in the past, right? So this is, a Model T. Let's take it back a century, and this is set in a museum in Cleveland. You can see it kind of very nicely exploded. All the different components that go in there, right? It's not a simple machine. It's got about 1,400 different components that go into this. But I think that if I gave you a clipboard that had a couple of exploded views and a full list of bill of materials, I'd wager that we'd have a decent chance, at least, at being able to understand and be able to produce this, with some reservations on that, right? So that's how manufacturing was done, right? And that was pretty cutting edge for the day, right? Assembly lines, all those things were pretty new and changing how industry worked. But if you want to contrast that with how manufacturing is done today, right, we're not talking about 1,400 parts to an automobile anymore, right? We're talking about 30,000. We're talking about not just one model that you have with 5 different colors. We're talking about dozens of models, all the customizations and trim packages that go into that. And we're also talking about something that's not slowing down, it's accelerating, right? The amount of complexity within a modern car is set to increase at least 50%, but could double every 3 years. And so if you take a look at this total picture of the complexity that's going into the products, the customers demanding the customization around that. But overall, they're not necessarily training or their staffs to act any differently from that. So this is an example of what is changing in the manufacturing space, right? In order to make more complicated products, we have to have more complicated engineering processes behind that. And that's where some of the problems start popping up. So what is the digital thread and why do you need it? The digital thread is really your solution to tackle the complexity of these problems. So if we look at the total product design stage, from exploring where a product fits and how it works, to the designing it, pulling that through to manufacturing, and then on to the service life, you need some sort of continuity to unite all of the different tools that are in that stack. So you need a way to manage your data. You need a way to circumvent bottlenecks in production and bottlenecks in information transfer. You need to close the gaps and eliminate information loss, right? You also need to help your entire organization collaborate and use the data efficiently, right? You don't want to be inefficient with it. Overall, the digital thread is like your conductor for an orchestra, making sure all of the disparate parts work together in unison, giving them direction, but also guiding them. So the digital thread is really the key to unifying a vision and then moving forward in a digital age with digital tools that are complex, that are complicated, that no single person knows every part of it. We like to simplify around EAC, so we talk about the digital thread, simply put, just delivers the right information to the right place and at the right time. That's essentially what we're going for. So that's our quick little intro. I want to introduce myself and my co-host today. So my name is Kurt Peterson. I am an IoT technical consultant with EAC. I worked as a manufacturing mechanical engineer and also as an automation consultant dealing with all sorts of PLC and HMI SCADA projects. So I'm joined today by Mr. Todd Liebenow, who's on the line with us. Todd, you want to introduce yourself?
Sure. Good morning, all. As advertised, I'm Todd Liebenow. I'm one of EAC's technical account managers. Been in the PTC space for coming up on 25 years. Background is pretty much covering all of PTC's MCAD items, functionality, in addition to a lot of the windshield functionality that we're going to cover today and more. So we'll keep the intro short and we'll keep moving, but that's us.
All right. So today we want to make this as interactive as possible. We're going to have a couple of poll questions for you to answer. We're going to have a couple of AR experiences that we want you to hit. So please don't sit back and just treat this like another webinar. We want your feedback. All the poll answers are going to be anonymous, and you won't have to worry about us knowing your data or sharing it with anybody else on the call. But we do want your feedback, right? After the presentation section of this, where we show you all of the different toys and how to use them, we're also going to have some breakout rooms because we want to hear from you. So the opportunity is there to bring your questions to us. And so we're going to have a couple of breakout rooms set up. So if you have a question for Todd on what's going on within the wind chill process, or if you have a question for me, what's going on in the IoT world, we want to help you out with those and get those answered. So stick around. We hope that this is as valuable as we can make it, right? We'd rather be doing this in person, but COVID being COVID, we're going to do the best we can in a virtual format. So without further ado, I'm going to turn it over to Todd, and he's going to talk about the engineering and design process, the start of the digital thread.
All right. Kurt, do you want to just run the slides, or do you want me to grab them here?
I am happy running with them if you are.
Okay, cool. I was going to make sure I'm sharing the right screen here. All right, so let me go ahead and do that. Share screen. And we'll pick this one. So let me know when you got my screen.
Looks like we got it.
Okay, cool. So we have that. So if you want to go ahead just to the next, I guess I should have let you keep the slides there for just a second, because I actually did want to cover a couple of things there. As long as we're here, I guess I can just run this. We said we're going to do one thing, but we're going to do another. Audible on the fly. I'm just going to build out this slide. So data management, your goal, you live in the middle of this complex product development process, right? Where you're challenged with innovating new products, getting them to market faster, and decreasing cost and complexity while making a quality product, right? No small task, right? So this is your world, right? And the challenges that you have, but then how are you going to manage all of this information? So it's not just simply vaulting the CAD data anymore. There's a whole spectrum of different items that go along in the product development process. There's specifications, different types of documents, spreadsheets, PDFs. You need to deliver information to both the customer for operating instructions as well as set up an installation, right? So there's lots of information that needs to go into this, and you need to manage all of this information, right? So I'm just going to go ahead and build out what we typically see on the left-hand side, a typical manual change management process. It's often very slow, very inefficient, meeting-driven, oftentimes with spreadsheets and information is scattered around the organization, oftentimes via paper, manila folders, those types of things. And one of the challenges with that is that there's not a lot of visibility into the time it takes to manage these changes, right? So who's made the change, did the change get done, and all of those types of things. So that's the current state. And so what we're talking about here is a future state or proposed state, a much more efficient, transparent process that's very loop-driven, change loop process as far as managing all the different items that go into your product development process, giving you more transparency across the organization, not just the people making the change, but people looking in to make sure that those changes actually get done and then track how long does it actually take to make those changes. So again, just going to build out the slides. I'm trying to get to the point where I actually show what this looks like in real life. But what we've got here is several different tools that help us manage this in the wind chill environment. So what we're doing is really tracking the issues that we want to address. Problem reports come in from different places. Might be the customer, might be from somebody in the shop. Then we need to look at validating that. Can we justify making that change? Do we need to make that change? And then finally, when we roll out those changes, we're going to let people know and then track back to make sure that those changes are completed. And like I said before, it's a closed loop process. We can go back in time and look to make sure that we did actually make these changes and track them just like a CAD drawing or a CAD part inside the system. So again, it's much more than just the engineering data. There's lots of other things that go into this information. So at this point, I'm going to pause. We can talk a little bit about BOM transformation, but we're going to hold on that for just a second. We'll come back in and show you what some of these things look like inside Windchill. So this is, if you haven't seen this is Windchill, and what we're looking at right now is the user's homepage. And so this is customizable, but I've got this to show here the user's tasks, and these are several different type of change items or tasks that have been assigned to me. And then I've got other things here, items that I'm working on. We can certainly dive into the Windchill environment and the interface in a breakout session. But what I wanted to show here is just the change items that are assigned to me, things I need to look at. So we're going to take a look at a specific change notice here. We'll take a look at this change guy right here. And so this is the change notice. This is the workflow that's associated with that. So it lists out for me what I need to do, the items that are associated with that. There might be other problem reports that flow into this, so it doesn't necessarily have to be a one-to-one mapping of that functionality. Right? So we might have several different issues that come up from the shop as far as fit and assembly and things like that. We can roll those into one change request and then roll multiple different change requests into change notification. So it gives you a lot of flexibility as far as how you manage these things. So this is just some of the details of a change notice that we're looking at rolling out. And we can go ahead and take a look at the specifics for that. So this would be the items that are associated here. So we've got, we're rolling forward changes into a specific new product for the next model year for snowmobile. And these are the items that are going to be associated with that. So we've got different accessories and things like that that are associated with this change. We can see we've got different tracks and other items that we're going to associate with that. So what does this look like? These are the items that are associated with that change. Now, it's not the whole entire snowmobile that we're changing. We're simply looking at the items that we're looking at making modifications to in this specific model year. So I can go ahead and do a comparison here as far as what this looked like last year and what we're proposing making a change to this year. So these are the items that let me just maximize the screen here so we can kind of see what we're looking at. And I'm going to change the filter. So we're looking at this guy right here. So we're doing before our change, like that. And so let's go ahead and see visually, not just the bill of material information, but graphically on the snowmobile, what's going to be different between the two different model years. So let's go ahead and roll forward, and I can just simply hit the play button here. And if I size this up, we can maybe see this a little bit better and zoom in on these guys. So here I've got something that's different in the Windchill module, right? So let's actually drill into that further and say, well, in the current model year, we've actually got this proposed for this year, and then we don't necessarily have that here. So we're actually making changes to the different model years, so I can quickly see what the differences are between last year's model and this year's model. So these are just some of the examples of what's going to be rolled forward into this change notice that we're rolling out. And so if I want to go back to this initial notification here, back to this first page here, when I go ahead and make those changes, I want to roll those forward. I have this task notification down here at the bottom. I can say, hey, I need to send that back for rework, or we want to make some additional changes, or we want to accept that. I can go here and actually complete that task, and then that will close that loop back to the original requester to let them know that those changes actually did happen in the system. And we can track those along with ETH activity and other details about those changes and when they were made. So that's a little bit about the change process. So then let's go back and take a look at the BOM transformation piece. So let me just go ahead and jump back into PowerPoint here. So this slide, interesting information. So a little story on my early life as a design engineer. One of my first jobs was to go out into the shop with a clipboard, like Kurt mentioned, and a number 2 pencil, and start at the front of the trailer and count all of the different items that were in there in that specific trailer. Because what we had found was that the CAD design at the time, a long time ago, we won't tell you how long, but a long time ago, the CAD design wasn't in sync with manufacturing, right? So there wasn't really a good way to track what was actually built based on the CAD models. So somebody had to actually go out and do an accounting for all of that. Hopefully that's not your scenario today, but occasionally we do still find situations where the bills of material for engineering as designed don't necessarily sync up with that information as built. And that's just a standard trailer. Then you factor in other items, different configurations, different customers want different lengths and heights and different accessories and those types of things. You add on all sorts of different options and variations in the model, and it becomes really, really hard to try and manage that. So if we look at a couple of different scenarios here, we've got, this is the interactive piece that we had mentioned before. You can go ahead and if you have the Vuforia View app loaded onto your device, you can go ahead and hit that QR code, And we've got some information here for a transformation, what it looks like in an augmented reality scenario. So you can do this directly from Creo Parametric. You can create this augmented reality experience, and you can use that for design reviews and sharing information across the organization. We've got a couple of those for you here. One the before bill of material transformation and one for after. Let's go ahead and take a look at after the bill of material transformation. What I've done here is change the configuration of the snowmobile with respect to the back seats and handlebars and that type of thing. If I click on the video here, you get an idea of about what that looks like when you load up this Vuforia view experience. So it's what I've done here is just record a little video on my phone. What this looks like, typically what you'll see, you'll go ahead and hit that QR code, and I'm going to put that in on my desktop here. So I've actually got that snowmobile on my desktop, and I'll go into landscape mode there so you can kind of see what that looks like. And you can interact with this thing, right? So that's me kind of zooming out, and I've got the instructions there that kind of show what that looks like as far as gestures, very familiar gestures as far as manipulating the geometry. You can kind of zoom in, zoom out. If you touch the different components there, you'll see that you've got an icon at the bottom of the screen that allows you to toggle off components. So you just touch them and hit the icon with the slash, and that will remove those components. You can sort of drill inside and see what's inside and behind the other items in the assembly.
And don't worry if you can't get this working. We can spend some time in the breakout rooms, kind of going over the same information. So, no worries. We're gonna press on it at this time. But yeah, so
sure. So that's just a couple of different options there for you. Either of those QR codes will work. One is the before the bill of material transformation, and one is after. And so one of the next things then is okay, so we've got this change management under control, and then if we need to think about bill of material transformation, what that looks like, let's actually show you one piece of what that looks like here inside Creo, or inside Windchill. Let me go ahead and take a look at this model.
So actually, Todd, real quick before we get to that,
right?
how about we do some poll the audience questions on how they do manufacturing at this point. So let's get some feedback from the group on the poll questions 2 for manufacturing. If we can start that poll up. So a couple questions for you about how you guys do manufacturing. Like I say, it's anonymous, so your candor is appreciated. And once we have those all in, if we could show the results so we can talk about them.
All right, it looks like we have everyone in. It looks like we actually had all of our voters answer for number 1, design engineering. So for who creates the documentation, which manufacturing uses to build and assemble products. And for number 2, we actually also had a full stream to vote for 0 through 5.
Gotcha. Okay. So interesting information. Thanks. Todd, take it away.
All right. So one of the things that I did want to talk about was a little bit of that BOM transformation piece. So if I go ahead and take a look at this is what that might look like. Let me maximize that again. So what we're looking at now is what we would call an upstream view, or think of that as engineering design. And the downstream view of that, you can think of that as manufacturing, right? So it's still showing bill of material information, but gosh, the way that manufacturing puts things together, it doesn't necessarily flow the same as what it looks like inside design engineering. We need the ability to manipulate that bill of material and get that to conform to what actually happens out in the shop. And so that's what we're showing here is tools that we've got that allow you to reconfigure. We're looking at the same information, the same set of data, but we're just restructuring it to look like we need it to inside manufacturing. So if I look at here, we've got a chassis module, and we've got lots of different variations for these snowmobiles, a couple different configurations for that. And what I'm showing here is if I pick on this chassis module, an individual here, I can say, hey, show me the corresponding items on the other side, and it's going to highlight these two items here. So I have a red option and a black option. But from the design standpoint, I'm not going to have a CAD model for a red version versus a black version, but in manufacturing, I absolutely do need to have that. And so this is the tools that we would use to show that specific information that I need for manufacturing. And so if I take a look at this further, right, so I'm kind of drilling down into that snowmobile one step further. This is what this would look like for a specific scheme. And if I said, hey, if I want to look at that in this tool, we'll go ahead and show you what that looks like. Specific details, a very flat assembly coming in here from the design side, right? So it's just a set of components. And if we just click on the visualization, so we can kind of see what that looks like here. But you can see that manufacturing has that configured very differently. And you might even think about this one step further downstream to say, hey, maybe I need to think about this from the service standpoint. What are the wearable items on that can create specific bill of material for that? So you can see I've regrouped this bill of material here, and it's as easy as simply dragging and dropping, right? So I can take components and drag and drop them wherever I need to in the system. Or if I need to come back in here and say, hey, you know what, in this kit, maybe I need to add an existing item, I can go ahead and do that right here. I can insert from existing and search across my organization here and say, hey, maybe I need to add some Loctite, right? So go ahead and do a search on that, and then that will go ahead and bring that in, and I can configure that and go grab that and add that. You're never going to have a CAD model for Loctite or those types of things, but you certainly need to have that and track that inside manufacturing. And it's just that easy to be able to do that. Then the last thing I was going to show here kind of ties in with the next slide. As long as we're here, I'll just go ahead and show that information. I need to create the engineering documentation for this for manufacturing, right? But that's the challenge, is who creates that documentation? Well, design engineering thinks manufacturing should do that because they know how they're going to put it together. But manufacturing engineering says, well, gosh, you know, you've got the CAD models, you've got the stuff, you can go ahead and just make the drawings for me that I need to go ahead and put this process plan together. Well, the long and short of it is that everybody's looking to somebody else to make that decision or make that documentation. But we can, you know, really we need to create that. And so what we'll do here is just say, I've got all the information here, different resources that are available that I need to put into this document. Different steps such as I've got different resources. Which factory is this going to be built in? Which assembly line? What tools do I need? What level assembler do I need? Do I need an inspector? So all of these other different resources and items go into this, much more than just CAD models and making an exploded drawing, with a few arrows and callouts, right? So that's the type of information that I can create. And then from here, I can go ahead and generate work instructions sort of on the fly, and it's going to build out this information for me. And I guess you got to reload the page here, but this will create the on the fly information for me to create the document. So that was what I wanted to talk to there. Let me go back to the PowerPoint piece on that. And this is really what I was thinking of, the details, the PowerPoint slide that kind of documents what I was just talking about. There's a handoff between design engineering and manufacturing engineering. How do we create that information? And that's really done here. Let me do shift F5 and take a look at that. We would structure the bill of material so that manufacturing can utilize that the way that they need to. And then you build out the process plan for that, including in all of the different resources. And the idea is that, again, we're following this digital thread concept from beginning to end, and it's just one of the steps along the way. This just happens to be manufacturing information that I can create, and everybody's looking at the same information and getting at the right place at the right time. So I think those are the items that I wanted to cover relative to change management, BOM transformation, and manufacturing or process documentation.
Awesome. Yeah, thanks, Todd. So that covers a lot of what the digital thread offers, mostly from the design side and handing it off to manufacturing. So I'm going to take it from here and kind of talk about from manufacturing onto the end of the digital thread, onto actual building and assembly, what that kind of looks like. So from that end of things, we've all been probably to an IKEA, and we've all probably assembled a desk. And what you get when you get those instructions, right, is you don't get big text-heavy words, which, might represent some of the work instructions that we have in operation today, right? IKEA gives you a graphical representation, some exploded views, some nice detailed drawings, right? It's pretty intuitive, and most people can do a pretty good job making a table with that. But I think, just like we've all seen IKEA drawings, we've all also had some problems with them, right? So the problem with these graphical drawings is as good as they are, they're not the best. They don't have all of the information that you could take somebody off the street and put them in front of it and have them actually configure that correctly. So we take those lessons of, all right, graphical instructions are great, but are they enough to give the proper tools to workers out in the field today? Because they've got a tough job. If we talk about what industrial operators are having to wrangle with in today's world, it's quite a bit. There's quite a few pieces that come into them. So number one, right, we spent a lot of time just talking about the accurate information data, right? So if you've got different variants going on, or if you've got different work orders going on, you've got a lot of different things going on. We need to just get them the right engineering docs, right? That's huge, right? That's what we've been talking about this whole time. But that's not the only piece that they have to juggle. They might have some smart tooling, right? Some torque wrenches or drivers or voltmeters or some different things that are connected to their quality system, right? That they have to use while they're constructing it, the product, to make sure that they're accurately and precisely building product. Operators also have to deal with different automation systems. So if you have to interact with a work cell or a robot cell, or if different machine lines, you're going to have to interface with the HMI on that, or maybe some coding, there's some different operations there. And the last piece is also the manufacturing piece, right? So there are work orders that need to come through. Maybe there's quality systems and quality checks that need to be done. So the operators today are asked to do really a dizzying amount in order to produce products. And it's a complicated job, and it's not getting any easier. Workforces around the country and around the world are having problems getting the right operators to do this job. So if we're not getting a better workforce tomorrow, what are we going to do to make sure that they can do the job today? So we talked about all those different pieces, and what we propose to do with the digital thread is use the digital thread to knit all of these different elements together in a single view. So if you want to get your work order in from your ERP or MES system and pair it up with the work instructions that we saw Todd create, then you want to put some time tracking on it so you know how long you're taking your job. You also want to know what your connected torque tools are. So you want to actually be able to pull data directly from your machine automated sources in order to give you quality checks, in order to give you better information. And the last part of this is also incorporate the operator's feedback, right? The human is a very powerful machine for different tasks like vision operation or intuitive critical thinking. You want to be able to capture the operator's input into your data automation system as well. So what if you could do that all within a single screen? That's kind of what we're going to be talking about when I show this demo. So from the end of the digital thread, what I'm going to be showing is something that we call Operator Advisor. And this is a module within the ThingWorx platform, which is an IoT platform that we're going to be talking about a little bit more. So what I want to start is I am an operator on the shop floor, and I get a work order for the snowmobile that Todd constructed earlier on. So in light of what we talked about, I want to get the work instructions. I want to have my graphical elements here, right? So I can take my model at each appropriate step, and I can get all the fidelity and all the detail that I want from it, right, down to the individual hardware pieces. So that's very nice. I've got up here, I've got the entire step order for the entire assembly. So if we wanted to, say, take a look at what the piece looked at once it reached the front assembly, if I wanted to take it all the way down, I could do that. But not just the work instruction, right? We're also connecting to a bunch of other information. So if I go here and if I look at my control characteristics for this step, I can see that I can associate my torque wrench with this step, and I've got my preset torque values already put in coming out of the work process plan so that I know I'm going to drive these particular set of hardware to exactly this torque setting, and then the system is going to check that, verify it, and store it and record so I have that within my process documentation going forward. So that's really where it starts to get pretty exciting for me, is that you're incorporating all of the benefits that you get from a human operator, and you're also incorporating the benefits you get from automated systems in terms of quality. The other thing that I want to highlight here is from a planning standpoint, right? If I am an operator and I hit start, I'm doing some operation, and then I complete it, by hitting these buttons, I am storing timestamps on when I produce these tasks. So let's zoom this out to a project level. I am able as a operations person to take a look at, okay, I know my operators, I know what they did, I know how long it took them to do each different step of the job. How is that going to help me optimize my workforce and optimize my process, right? I know all these things now where previously I wouldn't have had that information. So that's just a super quick view into what Operator Advisor can do. As the end of the digital thread, you're incorporating all these different pieces. You're connecting to enterprise systems, but you're also pulling in work instruction information that is maintained from Windchill to give you a really powerful interface that really empowers your workforce to work better. And we can dive into this longer in the breakout rooms, have all the playtime that we want. So going back to the PowerPoint, I kind of want to, we're moving through this quick, but I want to kind of just talk about everything that we've hit up to this point in terms of the digital thread. So Todd, do you want to kind of just quickly reiterate what we've all seen in this very short amount of time? Todd, did we lose you?
Let's try that. Is that unmuted?
Yes, sir.
All right, sorry about that. So, we blasted through a ton of information in a short amount of time, right? But let's actually summarize that by looking at this slide. And the typical design process starts with the CAD models, right? I mean, no great revelation there, right? But it's taking that information and leveraging that wherever it's required across the organization. So we provide tools for visualization and then reconfiguring, restructuring those bill of materials as needed. And you can account for different variations in the design, right? There's different options for your product and different ways that customers want to buy your product, and you want to accommodate that. And there's tools that help you manage that. And then we need to be able to transform those bill of materials so that people inside the organization, both purchasing and manufacturing, up and down the chain, can actually utilize that information. And then we can create, more information and better information for those people that need it, whether that's somebody out in the field doing service or repair or assembly instructions for somebody locally in the plant. We're getting them better information, and it's more accurate and it's timely. So it's all those things that are really wrapped together with the digital thread. So I think this is hopefully changing the way that you're seeing this from the tool standpoint. It's certainly changing how we share this information with you, rather than thinking about a bunch of point solutions and saying, hey, you should really look at this. Really helping you understand the true story and the benefit of the digital thread, tying together all of these different pieces of information that you typically had in your organization, and really weaving that together into a better process to help you make better products faster.
Awesome. The rest of our time from the presentation side today is I kind of want to pivot a little bit and talk about digital transformation overall. So, the digital thread is a pretty key aspect of that, but really where we talk about digital technologies doesn't end with the digital thread, right? In the industry at large, we're seeing that companies are really buying into digital platforms, and they're really buying into the different technologies that are allowing them to get data from more pervasive sources. They're allowing them to get data cheaper, and they're allowing them to aggregate, analyze, and use that data to drive powerful outcomes. It's really kind of the next step in engineering tools, right? If we think about what we've done as engineers over all of history, it's not really that different than what we're doing today, right? We're looking for different efficiencies. We're trying to identify inefficiencies. We're trying to eliminate bottlenecks. At the end of the day, our job is still the same, right? We want to make more parts. We want to make them quicker. We want to make them for less, and we want to sell them for more. So anytime we talk about digital technologies, we're still hammering towards these 3 points, right? We don't necessarily change our view on what the objective is. The only thing that's changed is our toolkit in order to go and pursue these objectives. So what I want to do now is take a little bit of a look at our smart factory. So EAC has just a little unit set up in Minneapolis that I'm going to be controlling here from my station. So this is it live right now in a workroom out there. And what I'm going to do with it is I'm going to show you a little bit of how I can connect to this remotely and how we can, start to get some insight from the different information that we're pulling from this. If I want to talk about the components real quick, what we have is just a simple screw that's attached to a Dobot machine that can pick up these marbles. It's connected to a PLC that's in the background running a couple of simple logic and photo eye sensors. That is connected to our Edge laptop that is actually connected to a cloud instance of ThingWorx. So what I'm going to do is I'm going to go ahead and hit my dashboard and log in and authenticate here. And I don't want to just look at this myself, right? I also want to invite you along with me. So what I'm going to do here is put this URL into the chat, and then I'm going to give you a login so that you can actually join me and look at the same information. So if you go to your chat and go ahead and click that link, and then it's going to prompt you for a username and password just like it did me. If you can use this login that's right after that in the chat, you should be able to view all of this without making any of the changes. So I'll let you go ahead and do that and kind of start this up. What you can see now is that we're at a basest level of nothing's going on. So I'm going to turn things on. And you'll see some screws start to move and some balls start to go. What this is an example of is a KPI dashboard where the critical operations of the factory, right? In this case, it's a simple little ball screw that we're talking to, but you can extrapolate. This could be whatever you want. This is an example of how I can get instant real-time information from my factory, from my facility, and use it to do something. So if I'm a plant operations manager looking at a couple different plants, I want to know how my OEE is for each different line on each different day. So you can see that that's what's happening here. We're seeing a couple of things start going. Our numbers are starting going up. Bad numbers go down, good numbers go up, and it's pretty powerful. So hopefully that you're also getting that from the dashboard that you have access to. The other thing that I also want to show, and I'm wondering why my Nest camera is not triggering here. We should be able to see motion. Nothing like a live demo. The other thing that I want to show here, there we go. So if I throw that back on screen, you can actually see that things are moving and screws are turning, robots are picking. I can also do a pick of a robot here remotely. So showing some of the remote control that I have through the ThingWorx platform. So the other thing that I want to do is also show you a digital twin of this factory. So if we go back to our PowerPoint presentation, and you take out your Vuforia View app, again, what you can actually put on is our digital twin of this factory. So now this is very cool because this is connected via live IoT data. When you put this experience on your desk or your floor, the digits that you're seeing, the gauges, are connected to the same KPI dashboard that you saw on your browser window. So that is very powerful, right? We talk about digital twins from using them from a simulation side of things, from using it from a planning and aggregation side of things. It's a very powerful tool that you can use, and here's ours. Again, I'm going to let you do this a little bit longer today, but if you want to see this again, we can play around with it in more breakout rooms. So that kind of concludes what we wanted to talk to in today's session. So again, where EAC kind of fits in this is we grew out of helping engineers use their tool set, right? We became very good at using tools, and then we took that forward and have helped people implement solutions for over 20 years within the PTC workspace. So that's where we sit. That's who we are. We have a couple people online today. Thank you for coming to our talk first and foremost. Hopefully this was valuable and that you learned something from it. We're going to have couple of breakout rooms, and we encourage you to, like I said, if you want to see more on one demo, if you want to dive deeper into a certain line of questioning, you have the opportunity to do so, and we would welcome that chance to talk to you. So I think that's all that we have for the presentation side. And if you would like to stick around, please do ask us all the questions you want, and then we can take it from there. So with that, I'll kind of hand it back to the moderator. But thank you all for coming, and look forward to your questions. So.